Hello everyone, and welcome back to the Argovis tutorial series. Today we are going to explore the Argovis API and how it brings Argo profile data into a programming environment. We will be using Python, but similar languages can be used, such as R and MATLAB. We wrote Argovis so that data can be easily accessed by people around the globe. For those who want to do more with the data than just viewing, perhaps make their own figure or perform some statistical analysis or machine learning problem, they should make use of the API. See the URL? The details that build this page view is all stored here. The map projection, pressure range, date, and more. If I send this link to a friend, they will replicate the view we are looking at. The API handles details stored in the URL so that the server can send the appropriate data. For the rest of this video, we will learn how to ask the server to send us profile data. This Jupyter notebook has some functions that build a URL from strings, making requests and returning Argo profiles. This notebook is available on my blog. The address is in the bottom right corner and in the description. The getProfile function gets a profile by its profile number, which is its float number underscored by a cycle number. This is converted into a Python data frame object. Next, we create a pressure versus temperature chart using our favorite library. We now can create charts in the style of XKCD. Using the getPlatformProfiles function here, will give us all the profiles for a certain platform number. Making a profile selection in a region requires a date range, shape array, and optionally a pressure range. This is a contour map with the data returned by our shape query. We have also built a metadata API query that will get all the profiles falling in a month and year. Measurement data is dropped to speed up the process. MongoDB has a payload size of 16 megabytes. That's why we break the API queries into chunks. These stack plots tell us details about the program. For instance, this legend represents data acquisition centers, or DACs, which are different countries that contribute to Argo. AOML is the American DAC, Coriolis the French, JML the Japanese. This plot displays the two main positioning systems used by Argo profiles. You can see that over time, GPS has surpassed Argos as the main way to estimate float position. This time series queries our selection every 12 days over several years. Observe how the temperature changes with each seasonal cycle. This last API makes a thin pressure slice globally over a date range. Like metadata API, only this time you do get measurements. You need to be careful not to exceed 16 megabytes, or else you will get an error message from the database. Using the getOceanSlice function to get the data, I then binned the number of profiles falling in 10-degree boxes around the globe. Finally, I made a map using the CartoPy library. And that's all we have to cover for today. Be sure to stay tuned for the next video. We are working on some data-derived products that will be on display in the next few months. Goodbye.